I am Mr. Taru. In this video, we're going to look at solving equations with the absolute value function in it, and inequalities. This video is intended for students in Algebra 1 and beginning into Algebra 2. So we're not going to be taking these absolute value functions and wrapping them around any kind of like crazy math functions like sine or cosine, or absolute values wrapped around a parabola, the equation of a parabola. So we're not going to get that complex, but we do need to, it's a starting point. How do you solve an equation or an equality with an absolute value symbol? Well, you isolate the absolute value function. You rewrite the equation without the absolute value function by separating it into two separate parts. One where you just simply drop the absolute value function, and another one where you replace the absolute values with a set of negative parentheses. Now you have to separate into two parts because the absolute value function says or explains or describes how far a number is away from the 0 on the number line. So if I said, well, what values are 3 units away from 0? Well, 3 and negative 3. 3 is 3 units to the right, and negative 3 is also 3 units away, but it's 3 units to the left. So both 3 and negative 3 are 3 units away from the center of the number line, or 0. So absolute value functions will normally have two answers, and certainly when we're solving them, we need to break that absolute value equation or inequality up into two parts, accounting for that left side and right side. I did that backwards. Left side and right side values from 0 on the number line. So we'll be doing that in a second with some examples. Solve each equation, each of the two that you've gotten from separating in step 2, and then check your answers. Make sure that what you got is actually going to work for the absolute value function or equation. So let's see what this is going to look like. We'll start off with a really simple example and then step it up a little bit in difficulty as we go, and also compare the equations with the inequalities. Number 1. Absolute value of x equals 8. Clearly there's no work here. The absolute value function is already alone, and there's really nothing inside the absolute value function. We're just going to show you how to pull apart the equation in two parts, and also show you why you want to keep one positive and negative. So absolute value of x equals 8. Well, we're just going to write x is equal to 8. Write the equation without the absolute value function, and then replace the absolute value function with a set of negative parentheses. So we have x equals 8, x equals negative 8. We're going to need to divide both sides by negative x, or excuse me, not negative x, negative 1, and we get x is equal to negative 8. And let's check that answer. Well, let's see. Is the absolute value of 8 equal to 8? Yes. And is the absolute value of negative 8 equal to 8? Well, the absolute value of negative 8 is positive 8, and that indeed works out as well. So a very simple example, you might argue too simple, but I'm showing you that I'm writing the equation without absolute value symbols at all. I get a solution that works. I'm not sure why I have this huge gap of empty space here, and then I take out the absolute value symbol and I replace it with a set of negative parentheses. Now, this is a little bit different format than my book and a lot of textbooks use. I like writing it like this, where I say that you take the absolute value function out and replace it with a set of negative parentheses because of working with inequalities. Now, what I mean by that is if I go back up here and replace the equal sign with, let's say, a less than symbol. So now we have x is less than 8, and by taking out the absolute value function and replacing it with a set of negative parentheses, you're going to see why maybe your textbook says it doesn't explain how to do your problems this way, but with inequalities it'll just sort of magically say, well, change the direction of the sign, and I'm going to divide both sides by negative 1. and get x is greater than negative 8. See, a lot of books will tell you when you break apart an absolute value function that you write the equation in its sort of given format, except you drop the absolute value. And then with inequalities, some textbooks will say that you change the direction of the inequality and put the negative on the other side. So some students will not understand completely why the inequality changes direction. So hence that's why I teach it the way I teach it. Okay, number line. So absolute value of x is less than 8 on the number line is going to look like this. We have 0, we have negative 8, we have positive 8. I did not include a equal sign, so this is going to be an open dot on 8 and shade to the left. This is going to be an open dot on negative 8 and shade to the right. And so thus we have, in this example, shading between negative 8 and 8. What would happen if we change the direction of the inequality? And my example was, I want the absolute value of x to be greater than 8. So the absolute value of x is greater than 8. Negative x is greater than 8. And divide both sides by negative 1 and we get x is less than negative 8. Now when I graph this on the number line, I get my 0, I get 8, I've got negative 8, I've got an open dot on 8, I shade to the right, I've got an open dot on negative 8, and I'm shading down. So as long as I use a number that's less than negative 8 or greater than 8, that's the solution to that absolute value inequality. So there's 3 examples, but only with just, x and 8. Not very much work there. So let's get into some meaty questions here. Some that require a bit more work. How about the absolute value of 3x minus 1 equals 14? My absolute value function is already isolated, so I'm going to break this apart and write 3x minus 1 is equal to 14. And parentheses, take the absolute values out, replace it with a set of negative parentheses. So 3x minus 1 equals 14. And then solve each question, independent of each other. Add 1 to both sides, and you get 3x is equal to 15. Divide by 3 to undo that multiplication, and you get x equals 5. Then over here, you have 2 choices. You can distribute the negative 1 through the parentheses, or you can divide both sides by negative 1 to get rid of that multiplication of negative 1. That negative in front of the parentheses acts like a negative 1 that wants to get multiplied through those parentheses because it's negative 1 times 3x minus 1. So we're going to cancel that out and get 3x minus 1 equals negative 14. We're going to undo that subtraction of 1 by adding 1 to both sides. Whenever you're trying to get something over the equation, you want to do the opposite. Negative 14 plus 1 is negative 13 over, well, it's going to be over 3 in a second. Negative 14 plus 1 is negative 13. Divide both sides by 3, and we get x is equal to negative 13 over 3. Now, sometimes you get solutions that don't actually work, so we want to check that, make sure it actually works out. So let's take the first answer. The absolute value of 3 times 5 minus 1 equals 14. Well, that's going to be the absolute value of 3 times 5, which is 15, minus 1 is equal to 14. That's the absolute value of 14 equals 14. Indeed, that actually does work. So our first solution is good. Let's try the next one. The absolute value of 3 times negative 13 over 3 minus 1 equals 14. These 3's cancel out, or you do 3 times negative 13 is negative 39 divided by 3 minus 1. Excuse me. This divides 39 divided by 3 is 13, so this is the absolute value of negative 13 minus 1. That comes out to be the absolute value of negative 14. And the absolute value of negative 14 is positive 14. So we have a check there as well. So we have a solution and they both checked out. If you were not given this problem as an equation, but if you were given this problem as an inequality, how would the work change? Well, it wouldn't change by very much. If I want 3x minus 1, the absolute value of 3x minus 1 to be greater than or equal to 14, solving inequalities is exactly the same as solving an equation, except for when you divide by a negative number. When you multiply or divide both sides of an inequality by a negative number, you are going to have to remember to change the direction of that inequality. And let's put that on a number line and move on to the next example. Here we have a number line. We have 0, 1, 2, 3, 4, 5. And we're going to have a closed dot on 5 because of the equal sign. And its x is greater than or equal to 5, so we're going to shade to the right. And where in the heck is 13 over 3? Well, you might want to make this into a mixed fraction before you bother trying to put it on the number line. 13 divided by 3. How many 3's are in 13? 3, 6, 9, 12. So this is going to be the same as x is less than or equal to negative 4, and then 3 times 4 is 12, giving you a remainder of 1. So that's negative 4 and 1/3. So negative 1, negative 2, negative 3, 4, 5. Negative 4 and a third takes you just a little bit beyond the negative 4 on the number line. Its x is less than or equal to, and x's get less than or smaller as you move to the left. So there's the shading of this solution. Next example. Alrighty then, we've got negative 2. Absolute value of x minus 4 plus 6 equals 10. Okay, this absolute value function is not already alone, so we're going to have to take a couple of steps before we're really ready to start this problem. We're going to subtract both sides by 6. You always want to add or subtract away from the variable. In this case, that variable is inside this math function, and then take care of what's touching last. So negative 2, absolute value of x minus 4. This is equal to 4. We're going to divide both sides by negative 2 and get the absolute value of x minus 4 equals negative 2. We now have the absolute value function isolated. But I don't really need to continue the problem. If you do, you're going to eventually come to the same conclusion when you try and check your solutions. And you may not notice that you made a mistake unless you do take those answers at the end and try and plug them back in and see if they work. Because you can continue this problem. Nothing will seem to be wrong. You will get those solutions when you're done, and if you take the time to try and plug them back into the original absolute value function, you're going to realize that none of your answers actually work. If you don't do the check, you'll never realize that, and you're going to get a lot of points marked off for that question. The absolute value of a number tells you how far that number is away from 0 on the number line. And there really is no such thing as a negative distance. From, this is saying the absolute value of something is equal to negative 2. Well, the absolute value of 2 is equal to 2. And the absolute value of negative 2 is equal to 2. An absolute value will never give you a negative answer as a result. Hence, This right here, the fact that we have negative 2 means that there is no solution. So if you continue on this problem and you find out what you think are values of x when you're done, if you don't check your solutions, you're not going to know that you made a mistake and that you should have stopped way back here. But this is no solution because absolute values do not give us negative numbers as a final answer. Moving on to the next one, we have absolute value of 2x plus 5 is equal to 3x plus 4. Okay, the absolute value function is already isolated, so we're going to break this up into two parts. So we have 2x plus 5 is equal to 3x plus 4, and we have taken out the absolute value and replacing it with a set of negative parentheses. 2x plus 5 equals 3x plus 4. Okay, we have variables on both sides of this equation, so I can move anything I like. I'm going to avoid creating a negative number and subtract both sides by 2x. And get 5 equals x plus 4. Subtract away from the variable, which I've put on the right-hand side. Don't you see that very often? So sometimes now students will start to make a mistake because the variable's on the right when they're used to making it on the left. You want to move away from the variable, and we have a plus 4 with that x. So we're going to subtract both sides by 4 and get x equals 1. Over here, now this time, just for the heck of it, I'm going to distribute the negative 1 through the parentheses instead of trying to divide it to the other side. And why would I? I've got two terms over there to deal with as well. So we've got negative 1 times 2 is negative 2x. Now it's negative 5 equals 3x plus 4. I'm going to, again, just to avoid some negative work, I'm going to take this negative 2x and add it to the other side. And get negative 5 equals 5x plus 4. Subtract both sides by 4. Get negative 9 equals 5x. Undo this multiplication of 5 by dividing both sides by 5. Again, doing that opposite math operation whenever you're trying to get away from the variable. And we get another solution of x equals negative 9/5. So all the algebra is good. We got a couple of answers that hopefully are going to work, but if we don't check them, we're not sure about it. So we've got, let's try number 1. Try the 1. So here's our check. 2, the absolute value of 2 times 1 plus 5 equals 3 times 1 plus 4. Do you see what I'm doing? I'm just taking the value of x that we found, the value of 1, and plugging it in where we used to have the x variables. So 2 times 1 is 2. 2 plus 5 is 7. And the absolute value of 7 is 7. Over here we have 3 times 1 is 3 plus 4, which is also equal to 7. And so our first solution of x equals 1 worked. Well, that's good. Let's try our other solution of negative 9/5. So where we did have a 1 in for x, now we're going to put in negative 9 over 5. So we've got 2 over, let's make that 2 look like a fraction so that we can see that we're going to multiply the numerators and multiply the two denominators. So 2 times negative 9 is negative 18 over 1 times 5, which is 5, plus 5. Now, I'm going to have to add these two terms if I'm going to actually check my work and not just be dependent on a scientific calculator. So I want to make that 5 look like a fraction so I can find the common denominators, because I cannot add fractions if I do not have common denominators. So I'm going to multiply this on the top and bottom by 5 and get the absolute value of negative 18 over 5 plus 25 over 5. That's going to come out to be negative 18 plus 25 is 7. And the absolute value of 7/5 is 7/5. Okay, let's try the other side. Make sure it actually is the same thing. We have 3 times -9, which is equal to -27/5, because that 3 is over 1, right? Just multiply the tops. And then 1 times 5 is 5. Plus 4. Well, again, you can't add fractions if you don't have a common denominator, so stick that 4 over 1, and we're going to multiply that second fraction on the top and bottom by 5 to get that common denominator. So we have -27 plus 20 over now our common denominator of 5, and we see what's going to happen here. -27 plus 20 is -7/5. Well, these are not equal. So this solution is no good or extraneous. So the algebra showed 2 solutions of 1 and -9/5, but the -9/5 does not work, and you will not know that unless you check your answers. Okay, one last example. Okay, let's throw something else in with a little bit of fraction work. The absolute value of x minus 4 over 2 minus 1 is less than 5. Well, I did last 2 with this equation, so let's stick an inequality in here. You cannot break up an inequality unless, an absolute value function unless it's isolated. So we're going to subtract both sides by 1 to undo that addition of 1. And we get the absolute value of x minus 4 over 2 is less than 4. We're now going to break this up into 2 parts because the absolute value function is alone. And we get x minus 4 over 2 is less than 4. And we get negative x minus 4 over 2, which is less than 4. We're going to go ahead and undo. Now, we have an equation with a fraction bar. Now, students generally hate fractions because they just take a little bit of extra work, and we're so dependent on calculators anymore that people just forget how to use them or do them. A fraction bar does mean division, yeah? So this is x minus 4 divided by 2. If I want to get 2 away from the x, I need to undo that division of 2. And the opposite of division, fraction bars mean divide, I'm going to multiply both sides of my equation by 2 to undo that division of 2. And they're simply going to cross out. They're going to cancel out. So we have 2 divided by 2, the multiplication of 2 and the division of 2 are going to cancel out. The fraction bar acts as one big group. It also acts as a grouping symbol, so I don't have to worry about the fact there's 2 terms on top. It's being grouped together by the fraction bar. So the 2's cancel out and you get x minus 4 is less than 8. Don't change the direction of that inequality because I multiplied by a positive number, not a negative one. Add 4 to both sides. X is less than 12. Over here, I'm going to divide both sides by -1 to, I don't want to take that negative, I could, but I don't really want to take that -1 that's in front of the parentheses and distribute it through. It'd be less work to just simply divide it over to the other side. And that process is going to, as you should, change the direction of the inequality, because I divided by a negative number, so the less than becomes greater than. Undo the division of 2 by multiplying by 2 again. That's going to cancel that out, and we get x minus 4 is greater than -8. So, add both sides by 4 to undo that subtraction of 4. And we get x is greater than -4. And since this is an inequality, let's go ahead and put that on a number line. So we have 0. Let's just do a quick sketch. We have -4 and we have 12. No equal signs, so these are open dots. X is less than 12. So an open dot on 12 and x values that are less than 12 are to the left. This says x is greater than -4. So open dot, again, because no equal sign. It says x is greater than, and your x's get bigger to the right. And that is the shading for my last example. I'm Mr. True. Go do your homework.